Dogs are waiting. They want to play with the ball. It's raining outside. I'm not standing in the rain and playing with you. You have to wait. Excuse the apple. I just wanted to make a quick video. I know. It will be a quick video. Future System 738 made a very good comment on my last video about the wrong or correct charging method of the PHEV. This is a very good addition, and I was going to address this situation a couple of times, but yeah, it just didn't fit in. So I'm now making a separate video about this issue. When actually should you charge your electric vehicle? And he's making a very, very good point. You should not come home at 4 or 5 o'clock in the afternoon and plug in your electric vehicle and charge it. Because this is peak time. This is the worst time to use electricity. It doesn't matter where you live. I mean, if you are in Norway, they have 97% renewable energy. Hydropower. That is maybe different over there because they've got enough free energy, which is clean. In Denmark, they have got so much wind energy. Might be okay there either. But still, at this point of time, everyone comes home, everyone turns on the air condition, everyone turns on heating, television, computers, light. Everything is being switched on, and the demand of power goes up, up, up. We've got this Energex website here with an app you can put on your mobile phone. You can see how much demand for electricity is at this point of time, and it's unbelievable how much up this curve goes at this point of time. And he's right, so please do not plug in and charge your electric vehicle or PHEV or anything else during this time, because it puts a lot of strain onto our electrical grid. And what they have to do is they have to fire up gas plants to deliver this demand of electricity then, because you can't if your electricity comes from coal plants, you cannot turn down the coal plant overnight when electricity is not being used and then turn it back on in the morning. This takes a long time. They are not fast reacting generators. What grid operators are doing, they have gas-fired electricity generators which they can just switch on like this, and they are producing instant electricity. But these generators are turned off during the day when the gas or when the coal plants are enough to supply all the demand. They have to be turned on in the late afternoon when everyone comes home, and there's a huge demand of electricity. So please always use your timer in your electric vehicle and time the charge after 10 o'clock or even later if you can, and switch it off at 7 o'clock in the morning again when everyone wakes up, and the same happens. Yeah, they're turning on aircon, they're turning on the television, the computer runs, they're cooking eggs and bacon, whatever. There's a fairly huge demand of electricity at these two peak times, especially in the afternoon. I am with a retailer who supplies me with 100% renewable energy 24/7. So they're buying enough wind energy to supply my demand of electricity. But still, every supplier has to cope with peak times. And if there's not enough wind energy available, the energy needs to come from somewhere. And here in Australia, it's most likely coal. And we want to use coal as less as possible, of course, too. And when you read through the comments, some people don't really care when they plug in, so they plug in the car whenever they come home and leave it plugged in as well, which is totally fine. And as someone said, if you don't do it for a week, it should be totally fine with this car. Yeah, it should not harm the battery. The management system and the whole design of the car, of the battery management system, of the battery itself, should take care of that. So don't leave it plugged in for a week or so. But if it's just for a night or for 1 or 2 days, that's totally fine. So the recommendation is use the Mitsubishi app, use whatever timer you have on your charger, use the Sonoff as I have shown you, so you can remotely disconnect and connect the car back to the charging system. Use whatever timer is available to you to avoid charging at the peak time. And Future System 738 is totally right. It is not green to charge your car during the peak time, because most likely this electricity is coming from coal and gas at this time. If you have solar, charge it during midday if possible, when your solar output is the highest, or delay your charge until after 10 o'clock. The demand goes really back. The coal electricity plants, they keep running, they keep just running. They are running 24/7 on basically the same output, because it's very, very hard to regulate them, and it takes a long time to cool things down and to heat things up again. So they keep them going. And if there's no demand overnight, the coal plant is kept on fire all the time, producing electricity which is not being used. And if you can source some of this electricity, it's at least not being wasted. A coal plant is a very, very delayed system, because once the coal plant is up and running, once the fire is started, it has a constant output of electricity. Of course they can switch and they can turn off turbines and everything, so they've got less or more output. The actual emissions and the input of coal into the coal power plant will stay the same. So we are wasting energy every night basically, just in case we have the demand there. And this is why our grid is so old and totally outdated. It's not made for this flexible demand we have in our grid. So when people coming home and using electricity, it's just not made for that. So we need far more renewable energy. We need battery storage. We need electric vehicles which are connected to the grid in both directions, so you can charge them and they can be discharged to cope with the peak times. Say you've got a 60 kilowatt hour battery in your car and you park at work and it gets charged with solar power for free during the day when the solar output is high. And then you drive home with this car and plug it back in to top it up at home. And when you go inside your house and turn on your air conditioner, your television, your oven, it takes the electricity out of your car, not out of the grid. So you would not participate at this peak time at all anymore, because the car is supplying your demand. And then when you go to bed and overnight, it just tops up the car again to be ready until the next morning. That would be an awesome system. And we are getting there slowly. I mean, the new PHEV has the vehicle to grid, vehicle to home system already implemented, so it can be done. And the Nissan Leaf has got the Nissan Home charging system, is it called, or something. So it is coming slowly, and now in Japan they are doing this technology for a couple of years now. And all these renewable and battery storage systems, they making this whole energy grid very, very flexible, because a charged battery can react in milliseconds to supply the it can react in milliseconds to supply the charge back into the grid. And there's pretty much no delay, and that's exactly what we need. We don't need coal plants it takes days to fire up a coal plant or to let it cool down, turn it off. So please read his comment on my last video, I'll link it below again, and act accordingly and responsibly. Okay, thanks for watching again, and we see us in the next video. Okay, bye-bye. Hello, ponies. Hey, Betty. Hey, Dave. They can smell the apple. Alright, 1 more hour and then you come over. Alright? 1 more hour. 1 more hour. Stay. Stay. I'm also charging my car on the non-peak. Okay, let me explain this. We've got 2 tariffs here. One is the 24/7. This is the normal demand tariff, which supplies your whole house, so you've got power every time and everywhere. And the other one is the peak 2 tariff. I think it's called peak 2 tariff or so. So they will turn off the power for a maximum of 6 hours on this tariff. So it's a separate circuit basically, and it supplies your hot water system, the pool pump, any larger any larger loads in your house with power, which does not necessarily to be turned on 24/7. And my electric vehicle charger is connected to the circuit as well. So whenever peak demand is high in the grid, they will turn off my electric car as well as the hot water, as the pool pump, and I don't know what else is connected to it actually. So this is an automatic thing from the grid operator to minimize peak demand. And I can see that they turn off the power regularly at this time so at the moment they are turning off the power from about 5 to 7 p.m. and then it runs for another 2 hours, and then they turn it off from 8:45 until 9:15, 9:30. That's when everyone has showers or whatever and uses more hot water. So there are 2 times a day when they turn off this circuit basically. So at least here in my area this has been taken care of, and they can flatten out the demand a little bit by turning off these high load devices. But at the moment, for example, I'm charging only with 6 amps because we have cloudy sky and the photovoltaic system, the solar system, does not supply too much energy at the moment. It's about 1.5 kilowatt at the moment, and I'm using 1.3 for the car already. So at the moment I'm charging the car with 100% of my own solar power, which should be the case always. Yeah, I just wanted to let you know about this tariff system. So there might be an option for you as well to switch your electric car charger to a different tariff. It's a little bit cheaper. I think only 3 or 4 cents cheaper than the normal tariff, but at least over time it sums up and you have a little bit of more savings on this different tariff for charging your car. I usually use the 6 amp setting on the EVSE all the time because it creates less heat loss in the battery itself. It creates less heat loss in the cabling, in all the installations. My Sonoff doesn't get that hot, so everything which produces heat is a loss. On the other hand, I'm not sure how efficient the electric car charger still is on 6 amp. I think it's more efficient when you have the high amp settings, the 15 amp, the 10 amp or the 15 amp settings. But I don't think it's too bad because I know from my solar power, from my inverter, from my solar system, and the efficiency stays up over 95% until it drops below 15 watts, which is basically nothing anymore. And only then, when you go under 15 watts, the efficiency goes down to 88, 85, 70, 60, 50%. And everything above 15 watts, it has almost the same efficiency as when you have the 5 kilowatt output of it. So I guess electronics are pretty good at this stage with efficiency factors. I hope the car charger is the same. Okay, it's a Mitsubishi product. I hope it's made in China somewhere, and the Chinese, they are pretty good in making efficient energy electronic. So I hope the car charger and the PHEV is very efficient in the 6 amp settings too. Okay, that's just to sum this all up. Okay, you stay charged and balanced, and make sure you don't charge between 4 and 8 p.m. at night. Okay, thanks for watching. See you, bye.